All right, 14.8, this is the final example. A little bit less standard than the other two, or other three, as the case may be. So what we'll do is we will find the double integral over R of x plus y over x minus y dA. Where R is the following region. So it'll be a triangle. It'll be bounded by these two lines. So this is the line y equals x plus 1. This is the line y equals, say, 5 minus x, and then the vertical line x equals 0. Not a perfectly drawn picture, but that's okay. So this isn't really that nice of an integral to do in this case, because it's not exactly easy if I did it as horizontally or vertically simple how we would actually integrate the integrand. And so what we'll do is we'll make a substitution. So the question then becomes, what could the substitution be? So in the spirit of the first couple of problems, what we might think of doing is we might look at these original lines. So let's number these 1, 2, and 3. It's a little bit different than before though, but let's try some rewriting. So 1 could be rewritten. So let's look at the lines. So 1 could be rewritten as y minus x equals 1. 2 could be rewritten as x plus y equals 5. Now, those are different and they suggest some substitution. So this first one might suggest u equals y minus x. That's sort of appealing because the denominator in the integrand is x minus y, which is negative u. That's sort of nice. This might suggest v equals x plus y, which is nice because the numerator in the integrand is then just v. But then we have this last guy, this x equals 0. We don't want to add another variable to the mix, so what can we do with this, right? So just to reiterate, these two right here, they're nice for the integrand, but also they make the lines really nice. This makes u equal to 1. This makes v equals to 5. Those are nice. But how about this x equals 0, right? So what we could do is we could look at the substitution we just made. So to do this, look at our substitution. All right, so if we take the substitution, we can solve for x, right? So what we can do is, let's do this. Let's solve for x. So the first equation is negative x plus y equals u. The second equation is x plus y equals v. Right? That's from the substitution that we've made right here in blue. I just rewrote the first one. So if I add them, I'm going to cancel the x. So let me negate the first one. And leave the second one alone. And then add them. And then I get 2x equals v minus u, or x equals 1/2 v minus u. And so this third line, x equals 0, from this, let's say then x equals 0 becomes 1/2 v minus u equals 0, or v minus u equals 0, or u equals v. And that's also nice. So all of this tells us that the S is as follows. Right? In the UV plane, we've got an edge at u equals 1. That's right here. Edge at v equals 5. That's right here. And then an edge at u equals v. So that's right here. So this is our S. And that's a pretty nice region. It's vertically simple, it's horizontally simple. Has a nice meeting point that we can find up at 5, 5 and at 1, 1. Everything's good. So what do we need to know here? We need to know the Jacobian. We need to know what the integrand changes into. So for the Jacobian, again, we have u equals and v equals. We'll use that version. The Jacobian is 1 divided by the determinant of partial u partial x, partial u partial y, partial v partial x, partial v partial y. This is 1 divided by the determinant partial. This is all coming from the formulas in blue on the left. So partial u partial x is -1. Partial u partial y is 1. Partial v partial x is 1. And partial v partial y is 1. So this is 1 divided by, this is -2 minus 1, or -1 minus 1 is -2. This is -1/2. So then the integral over r of x plus y over x minus y dA, this becomes the integral over s. So in this numerator, the x plus y, that's the same as v. The x minus y, that's the same as -u. And then absolute value of -1/2 dA. And then that's all pretty nice. So S is vertically simple. So the u's go from 1 to 5. The v's go from the upper function, which is v equals 5, to the lower function, which is u equals v or v equals u. And then we have a 1/2 because the absolute value kills the negative. We have a negative that was there and a v over u. And then dv du. And just to reiterate, because there's one thing that may be a bit confusing here. This lower integral, this is v equals u. This upper one is v equals 5. Those come respectively from up. I'm going to label the picture up top. That lower line is v equals u. That upper line is v equals 5. So those are the two that feed into this problem right here. And then this just gets evaluated. So this one's not so obvious because it's not clear, like it's some random triangle. It's not a simple parallelogram. We have to sort of test the substitution a bit. We see in blue the substitution that we're suggesting that seems reasonable. Then we have to figure out what to do with this third line. Now this x equals 0 to give us the final result. At the end of the day, not too bad. The Jacobian is pretty easy. The substitution for the final result is pretty easy, and the final integral is pretty easy to evaluate.